Security researcher and his interest lies in finding new attacks and vulnerabilities. He maintains an online HTML5 security blog, and he's a speaker for Black Hack Abu Dhabi this year. So, what are the thanks?
Can I use this? Like I said, I'm Kumar and I do some work on HTML5. So do that. Oh, okay. I probably don't need this. Okay, so this particular talk is going to be on how HTML5 can be used to attack users and web applications, right? So that's what this talk is about. And anybody has used HTML5 or read about HTML5 in this room? You have? Okay, cool. So I guess for the rest of you, HTML5 is going to be a pretty relatively new concept, but I'll go over the features that that'll be covered in this talk. So you should be able to follow the problems. And another thing is, I've got tons of things to cover, so maybe there would not be time at the end for Q&A. So if you have any questions, you just stop me right there, and we can get it sorted out. Okay, so this is my introduction. I'm a web security researcher. I run attack and defense labs along with Manish, and I'm working as a penetration tester at a financial organization. I've written a couple of tools, Imposter, Shell of the Future, and there are a few more that I'll be releasing at this talk. Okay, so this is roughly what you can expect from this talk. I'll quickly run over what HTML5 is. We'll see how existing HTML4 websites can be attacked using HTML5. We'll see how we can do network reconnaissance with HTML5. We'll see how HTML5 botnets can be built and what are the kind of things that these botnets can actually do. And there'll actually be two new tools that I'll be talking about. One is Ravan, the other one is called JS Recon. Alright, so let's talk a little bit about HTML5. It's the next major version of HTML, right? So it's got tons of new things, and all of them are in the form of new HTML tags or new event handlers for existing tags, and you also have a lot of new APIs. So what's basically happening is your JavaScript can now do a lot of other things which was not possible earlier, because there are a lot of new APIs that it can actually call to. And so one of the major objectives behind HTML5 is to provide native support for a lot of things which are currently only possible using plugins like Silverlight or Flash. Right, so I think you might have heard or you might have read an article wherein the chief editor of HTML5 actually said that it will probably only be completed by 2025, and it's only for adoption at probably early 2020. But the thing is, the browser vendors have actually been trying to implement HTML5 already. So you might be using HTML5 already, and you might not even know about it, right? So all the latest browsers, if you're using Chrome, Safari, Firefox, Opera, they already do support HTML5, right? So you do actually have HTML5 right now on your machines, right? So it's not 2020, it's 2010 that we're talking about. Okay, so is HTML5 really broken? The answer is no. Folks who have been designing it have put in a lot of effort to actually make it as secure as possible. But the thing is, it's actually impossible for you to design a new feature and not create an additional area of exposure, which somebody can actually abuse. So what we're going to do here is we'll just be abusing these new features which are available with HTML5. So these are some of the HTML5 features that I'm going to cover. Like I said, new tags and attributes in HTML5. Cross-origin requests, drag and drop API, application cache, web sockets and web workers. I'll go over in detail as to what these things mean when I get to the particular section. Okay, so the first thing is cross-site scripting with HTML5. We'll see how HTML5 can basically help you with cross-site scripting attacks. Right. So one thing that we're going to look at is blacklist cross-site scripting filters. Right. So there are a lot of websites which actually use blacklist filters for preventing XSX vulnerabilities. And one of the common places where this is required is when you have to accept some kind of rich content from the user, right? So let's say, for example, it's a form where the user can input bold tags, italics tags, and those kind of tags. So you want to allow some kind of HTML from the user, but then you don't want him to include script or tags like those. So what you do is you write a blacklist for those bad tags, right? So, and this is very common when you're looking at features like these. The problem with blacklists is they're almost always bypassable, right? But developers are usually not aware of that, so they normally tend to use blacklists. So we'll see how HTML5 can be used to bypass blacklist filters. One of the common things that folks filter for is the tags like script and image. Let's say there's a filter where they're specifically filtering these kind of tags. So with HTML5, you actually have new tags. You have the video tag, you have the audio tag, and these tags can actually execute JavaScript, right? So instead of writing script source blah blah blah, you can just say video on it, and your script is going to execute and it's going to bypass this blacklist, right? So you don't have to try anything fancy. It's actually very simple. You just have to try these new tags. Okay, now then let's look at another type of filter which is probably a little bit more difficult to bypass, because what it's doing is it's filtering of lesser than and greater than tags. So now you cannot inject any type of HTML tag into it, right? But let's say, for example, the data that we are injecting is actually being reflected back in an event handler, right? So now you can execute JavaScript without actually injecting HTML tag. But the problem is the filter is blocking well-known event handlers, right? So on error, on loads, these are the normal attributes that you use to execute JavaScript. So let's say the filter is blocking those, but HTML5 comes to the rescue again because it adds new kind of event handlers, right? So you have ones like on-form input and on-form change. So these are new ones which could bypass these filters. And so let's look at the third type of filter, which is probably even more restrictive, right? So I spoke about on-form input and on-form change. Now let's say there is a filter which blocks everything that starts with on, right? So on error, on load, or whatever it is. So it's got a regular expression like this. So it's going to block even those two attributes, right? So but then there are other ones like form action. So again, this is the new attribute in HTML5, and this is going to bypass this filter again. Okay, so these were some filter bypasses using HTML5. Another thing that you could actually use is when there is cross-site scripting, where the user entered data is being printed back within an attribute of the input tag, right? So this is very, very common. If you're doing pen testing, this is probably one of the most common types of cross-site scripting that you will come across. And normally when you see an XSS like this, the only thing that you will normally do is say on mouse over and then execute the script. So when you say on mouse over, you basically require user action. The user has to move his mouse over the input box, and only then the script will get executed, right? But with HTML5, you can make this automatic because you have an attribute called as onFocus. So you say onFocus, you execute the script, and then there's another attribute called as autofocus. So when you say autofocus, this tag will automatically get focused, right? And once it gets focused, the onFocus attribute is executed and your script is going to run, right? So all this information is from the HTML5 security cheat sheet, which is maintained by Mario, right? So these are the URLs where you can actually get access to them. So he's got like a bunch of XSS vectors, and he keeps updating them, on a regular basis. So if you're doing pen testing, this is something that you should really know about. Right. So what I'll do is I'll very quickly show you a small demo of the filter bypasses. Right. So this is a simple input box. If I say script source, for example, and let's say there's a blacklist filter here. It's telling me that an excessive tag is detected. The same happens for image as well. So to bypass this, what I'll do is I'll try the video tag, and it goes down, right? And most people never update their blacklist filters, and these tags are relatively new. Very few people actually know about them. So there's a very good chance that these tags have not been filtered. Right. So I was talking about automating the input attribute injection. So before HTML5, if there was XSS in an input tag, this is what you would do. You would say on mouse over alert or something. So now XSS, the script is not getting executed. You would have to actually move the mouse over it. So it requires user interaction. So with HTML5, it's very easy. You just say auto focus and boom, right? Okay, so that was filter bypassing with HTML5. Now, any questions on this, or we can move on to the next one? Alright, so I guess everybody's clear with that. Right, so the next thing that we're going to look at is reverse web shells with cross-origin requests. Now, anybody who's into web applications, know that the primary security principle of browsers is the same origin policy, right? And if you have used Ajax request, which is XML HTTP request, you know that an XML HTTP request can only be sent to the same site from which the script was loaded, right? That's the same origin policy. Now, HTML5 actually completely breaks this model. So in HTML5, a script loaded from any domain can send an Ajax request to any other domain, right? There are some restrictions on reading the response. Let's say, for example, a script loaded from Google, right, is sending a request to Yahoo. It can send the request to Yahoo. There are no restrictions on that. But if it has to read the response, then Yahoo actually has to opt in, right? So Yahoo has to say, yes, I would like Google to read my response, right? So as long as Yahoo says that, Google can actually read the response from Yahoo.com. So this is the header that has to be set, access control allow origin, right? So if Yahoo says access control allow origin google.com, right? So any script from Google can send the request and read the response back, right? So if you want to do cross-domain communication, that would actually becomes very, very simple. So what I've done is I've taken this feature and I've turned it into a reverse shell, right? A reverse shell where you're basically tunneling HTTP traffic over Ajax request, right? So I'm calling this a web shell because the reverse shell is not a command prompt, but it's actually the user's browsing session, right? So the way it works is pretty simple. What you do is you inject your script into the victim's session. You do this by cross-site scripting or by getting him to paste the JavaScript in his URL. His address bar, right? So either way, you inject your JavaScript into the victim's browser, and once you do that, this injected script is going to talk back to the attacker's machine using cross-origin request, right? And when it's talking back to him, the attacker can say, fetch me this page. So when he says that, this page is fetched from the victim's browser. It gets the response and sends it back to the attacker's machine, right? So that's how a reverse web shell works. And so the tool I've written is called a shell of the future. I'll be showing you a quick demo of this. It makes the whole process of getting a reverse web shell extremely easy. And in fact, if you want to prove the impact of a cross-site scripting vulnerability, this is probably the best and the easiest way to do that, right? It can scare folks who normally do not know how serious a cross-site scripting vulnerability is. Right, so this is the architecture of Shell of the future. I don't have much time, so we'll probably won't go into details of this. I'd much rather show you the demo. Okay. Okay, so this is google.com open from Chrome, right? Let's assume this is the victim session, right? And